Question 9. Nicola travels to work by train or by bus or by car. Table gives some information about her 300 journeys to work last year. So there's your 300. One of the days that Nicola travelled to work last year is picked at random. Find the probability that she travelled by train and was late for work on that day. So we need train and we need late, and it's out of all 300 days. So train and late would be this one here, 42. So 42 over 300, we can simplify that to be 21 over 150. That can simplify to be 7 over 50. So that'll do as our answer, 7 over 50, or 14% of the time, or 0.14. But it doesn't stipulate change anything in particular, so a fraction is absolutely fine. The absolute risk of Nicola arriving late for work last year when travelling by bus is 0.4. That's essentially saying that that's the probability of her being late, arriving late and by bus is 0.4. Show why the value of x in the table is 24. So here's our x up here. So if I was to do x divided by 60, so the number of lates over a number of times she actually took the bus, that would give me an answer of 0.4. So rearranging that, multiply both sides by 60. So in our calculator, 0.4 multiplied by 60, and that gives us our 24. So that equals 24. So that's why x is 24 above. Do make sure that you've got those calculations, including the multiply by 60. That's the important bit there. Part C. Show that the relative risk of Nicola being late for work last year when she travelled by car compared when she travelled by bus is this amount. So we want travelling by car, which would be, and again we're looking at, it was late, so it's late by car would be 22 over 80, and then late by bus would have been our 24, which we had here, out of 60. So that's our late compared to the number of journeys. What we do with these numbers, calculate the relative risk, is divide those two fractions. So what we end up with is 22 over 80. Remember your keep, change, flip. So that'll have to be multiplied by 60 over 24. What I could do is simplify this actually a little bit. So 22 and 24, 2 will divide into those, so 11. And I'll have 12 here. The 60 and the 80, 10 will divide into both of those. Actually 20 will divide into both of those. So that would be 3 and that would be 4. So I'm just trying to get some simplifying in beforehand. So we end up with 33 over 48. And I could divide this actually again by 3, I reckon. So that would be 11 over 16 as my final answer, which actually is our answer there. So if you don't get to 11 over 16, you've done something wrong. We're just showing here how I get to that 11 over 16. And lastly, interpret this relative risk. So what I would say here is, so that's the risk. So what I would say here is, given that number, lateness, or it is more likely to be late by bus than it is to be late by car. So that's just a case of comparing the bus versus the car, in terms of lateness.